Hello again, welcome to another lesson in Algebra 1. Today we are covering section 10.2 part B. So this is the second day we're spending on this section. And today we're just going to talk about minimums and maximums as we review what we learned the first time. Alright, so warm up, review. This is an old review. Solve each system of equations using any method you want. And our exam is coming up soon, so we want to make sure we're starting to practice some of these things we learned earlier in the year. So remember, the easiest way to solve a system like in number 1, when all the x's, the y terms, the equals, and the constant terms are lined up, is using the elimination method. So I'm going to take the second equation and times it by 3, so the y's are the same. So this will now become 2x minus 3y equals 5, and 18x minus 3y equals 21. So since the y values are the same, I'll do subtraction to make them go away. So 2x minus 18x is negative 16x. And negative 3 minus negative 3, that would give me 0y, so that made the y's be eliminated. That's why this method was called the elimination method. And 5 minus 21 gives me negative 16. Well, that worked out nice, because if I divide both sides by negative 16, I just get x equal to 1. And that's half of my answer. So remember, the answer to a linear system is the ordered pair where the two lines cross. Okay. So we get 1. We plug 1 back into either one of these equations. So I'll do it into the first one. 2 minus 1 times 3y, or minus 3y equals 5. So subtract 2 from both sides will give me negative 3y equals 3. And y is negative 1. So this is the ordered pair where these two cross. Okay, remember, you can do a check by plugging this back in for x and y in both of these and making sure that they make true statements. Okay. All right, so let's do that really fast. So this would be 2 plus 3. So 2 times 1 minus 3 times negative 1 will turn into 2 plus 3, which does equal to 5 on the other side. And for our other one, let's see, 6 times 1 minus negative 1. So 6 minus negative 1 is 7, and that's the answer for the other side too, so it does work. All right. Number 2 is halfway solved for us. So this is really nice. X is 3. It's one of our equations. This says x is always 3 for this line. And then all I need to do is plug it back in for the y, or for the x, and solve for y. So this will give me 6 plus 9y equals 15, and 9y equals 9, so y is 1. So our answer in the second one is the ordered pair 3, 1. So remember, these are the ordered pairs where the two lines cross. Okay, the intersection is the solution to both. All right, give the quadratic function f of x equal to x squared minus 2. What is the value of f of x when x is 2? So this just says, hey, if I let the input be 2, what's the value of f? So this is, what is s value when the input is 2? So I plug 2 in over here. 4 minus 2 will give me 2 for the final answer. So the output will also be 2. Number 2, given the quadratic function f of x equals 2x squared, what is the value of f of x when x is negative 3? So once again, this is saying, what is the output when the input is negative 3? So I'll go ahead and plug it in. What's my input of negative 3? Okay, so this will turn into 2 times 9, which is 18. Remember, with substitution, you're always supposed to substitute with parentheses. It doesn't really matter unless we have some kind of exponent on what we're substituting for. So be very careful to make sure you put parentheses around the ones with exponents. Okay. All right, find and label the axis of symmetry and the vertex for the quadratic function f of x equals 3x squared minus 6x minus 7. So this is a review from part 1. So the a value is 3, the b is negative 6, and the c is negative 7. And to find the axis of symmetry, we use the formula x equals negative b over 2a. Okay, so in this case, negative b would be negative negative 6 over 2 times a, 2 times 3. So that's 6 over 6, which is 1. So our axis of symmetry is x equal to 1. This is the vertical line that splits the parabola in half. Okay? So the vertex, which is the lowest or highest point on that parabola, is going to have an x value of 1. We just need to find the y value that goes with it. So, or in this case, the f value. So I plug in the 1 for my input. So give me 3 times 1 squared minus 6 times 1 minus 7. So that's 3, 1 squared is just 1, minus 6 minus 7. And 3 minus 6 is negative 3, minus 7 is negative 10. So this is my vertex, 1, negative 10. All right, let's flip it over. Okay, on the top of our second page, number 4 says, accurately graph the quadratic function f of x equals negative 2x squared plus 8x minus 2. So be sure to draw the axis of symmetry. That means you have to find that. Label where the vertex is, and to clearly mark at least 2 points on each side of the axis of symmetry. So remember that our vertex is on the axis of symmetry, so we just need to label that point and then 2 extra points on each side. All right, so let's see. Axis symmetry first. This is going to be x equals negative b over 2a. So negative 8 over 2 times negative 2. So that's negative 8 over negative 4, which is positive 2. So our axis of symmetry is x equal to 2. All right, our vertex is going to be 2 something. So I'll plug the 2 back in. So f of 2 equals negative 2 times 2 squared plus 8 times 2 minus 2. So that's 4 times 2, which is negative 8, plus 16 minus 2. So negative 8 plus 16 is 8, and 8 minus 2 is 6. So my vertex is going to be at 2, 6. All right, so this parabola is also going to open downward because my a value is negative. Okay, so a, which is equal to negative 2. Okay, all right, and that is less than 0. All right, so let's plot our axis of symmetry and our x and f axis here. All right, so since it's opening down, we want to leave as much room as possible. So we know the highest it gets up is 6. So 1, 2, 3, 4, 5, 6, 7. I'll go ahead and put my x-axis about here. This will leave room for us to plot the vertex and still have a lot of room to go down. I'll move my f-axis here a little bit to the left of the center so that I have some room to plot my parabola right in the middle. So our axis of symmetry is at 2. Remember, this is not part of our parabola. It just shows the middle of the parabola. It's like an extra piece. All right, and our vertex is at 2, 6. So 2 over and 1, 2, 3, 4, 5, 6. Okay, so there's our label the vertex, label the axis of symmetry, and now we need to get 2 points on either side. Okay. All right, so x and f, sorry. So we've already used 2, so I'm going to use 1, and I'm going to use 0. And the 0 one's easy to find. That's our f-intercept. Okay, so when c is negative 2, that means the f-intercept, because we don't have a y-axis this time, is equal to negative 2. Okay, so that's the place where it crosses the f-axis. So there's my 0, negative 2, and then 2 over on that side would also be in the same spot. Okay. And I'm going to go ahead and plug in 1. So let's see, negative 2 times 1 will give me negative 2, plus 8 will give me 6, and 6 minus 2 will give me 4. So at 1, we would have 4. That's right here, and I can mirror that over. And I'll go ahead and plot my parabola. So I've got the minimum amount here. All right, and there is f of x equal to negative 2x squared plus 8x minus 2. All right, I plotted my vertex and 2 points on each side. Okay. All right. Minimum and maximum values. For y equal to ax squared plus bx plus c, the y coordinate of the vertex is the minimum value of the function if a is greater than 0, or the maximum value of the function if a is less than 0. So let's see why. So a minimum value if a is less than 0. So if a, or maximum value, sorry, if a is less than 0. So if a is less than 0, that means our parabola is going to open downward. So we can draw an opening downward parabola. And it makes sense that the max would be the top of this, because it never goes above that point. Okay? If a is greater than 0, this means our parabola opens upward. And this makes sense for a minimum because the parabola never gets lower than that vertex point. Okay? So in both of these cases, if we make a chart, XY chart, at some place we're going to hit some X that's going to give us a max over here for our outputs. And over here, at some X, we're going to get a min for our outputs. So the smallest number possible in the table and the biggest number possible in the table. Okay? All right, so this is not too bad. We already know how to do that because that's going to be on our vertex. So all we're really looking for is the y coordinate of our vertex. And we know how to find these x's. This is just the formula negative b over 2a, where our axis of symmetry is. Okay? So find the minimum or maximum for each quadratic function and be sure to label whether it's a minimum or maximum. So this is not new, it's just an extra step here. All right, so first we're going to find our axis of symmetry. So negative b over 2a is negative 25 over 2 times 5. So that's 25 over 10, which is 2.5. All right. So that tells us the x where our vertex will be. We need to know the y part. So I'll plug that back in. Y equals 5 times 2.5 squared minus 25 times 2.5 plus 100. And I'm going to get a calculator and type this in. Okay. So I have 5 times 2.5 squared minus 25 times 2.5 plus 100. And I get 68.75. Now we're not asked to graph this, so this isn't bad. So now this 68.75 is either going to be a minimum or a maximum. Well, how do I know? The a value is positive, so this parabola is a happy face. So this means we're going to have a min. So our final answer would say the minimum value is 68.75. Number 6, so same thing over here. We're going to find the axis of symmetry first. Negative b over 2a. In this case, b is 0, so negative 0 over 2 times negative 6. Well, that just gives me 0. All right, and then I'll plug the 0 back in. So f of 0 equals negative 6 times 0 squared plus 6. Well, 0 squared 0, so 0 times negative 6 is still 0, and 0 plus 6 will give us 6. All right, so we just need to know whether this 6 is a minimum or a maximum. So the a value is negative, so this makes this a frowny face. So we're going to have a max this time. So the maximum value is 6. All right, let's flip this over and see what's on the other side. Okay, on the back we have 2 word problems. Number 7 says the suspension cables between 2 towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by this function. So let's draw a picture of what this looks like. So here's 2 towers above the water. And here's the bridge. And we have a suspension bridge, so it's held up by wires like this. So we're looking for that thing, that parabola right there. Okay. All right, so what is the height of the cable above the water at its lowest point? Okay, so we just want to find the minimum value, so the lowest point on this parabola here. All right, so the same thing as before. We'll find the axis of symmetry. So negative b over 2a. This is negative 0.37 divided by 2 times, let's see, that's 4 zeros, 3, 4, 9, 7. All right, so I'll type this on my calculator. So negative of negative 0.37, that's just 0.37, divided by 2. And I'm going to put parentheses around my bottom, so I do the timesing part first. 2 times 0.000097. Okay, so this will give me 1907, or about 0.21 or so. So I'm around to the nearest hundredth, which would be 0.22. Okay. All right. And then we want to say, what is the height of the cable above the water at its lowest point? So I just need to plug this back into my function. So y equals 0.000097 times 1907.22 squared minus 0.37 times 1907.22, and then plus 549. Okay, so we'll type this in, and this will give us our minimum height above the water that this cable gets. So let's type it on the calculator, 0.000097, parentheses 1907.22 to the second power, minus 0.37, parentheses 1907.22, and then plus 549. And I got 196.1 something, so about 196.2. All right, so we just write our answer. What is the height of the cable of the water at its lowest point? The cable's height at lowest point is about 196 feet. All right. Okay, let's take a look at the next one. We have this formula here again for the height of an object in feet based on its initial velocity, upwards velocity, and its initial starting height. Okay, so they gave it h of 0 for its initial height instead of s for starting height this time, and v of 0 for its initial velocity. So these little v of 0 just means velocity at time 0, and this one means height at time 0. Okay. All right, so Mike's catapult launches a marshmallow from the top of a school roof. So here's our school roof. Here's a little catapult, and it launches a marshmallow. Okay. All right, so it's height of the school roof 30 feet above the ground. His catapult launches the marshmallow up in the air with the initial velocity of 20 feet per second. How high is the marshmallow when it reaches its highest point? Okay, so we need to write a parabola for this height. Okay, so a formula. So we have negative 16t squared. So there's our part of our parabola formula. We have the velocity, initial velocity of 20 feet per second. So we put that in for v of 0. So 20t now. And we replace h of 0 with our starting height. And we know it started at 30 feet above the roof. So we want to see, hey, what's the top of this parabola? Because this thing shoots like a parabola, and we want to know the maximum value. How high is the marshmallow when it reaches its highest point? So once again, we're going to find the axis symmetry. In this case, our input is t. So it's going to be, variable is t, so it's going to be t equals negative b over 2a. So negative 20 divided by 2 times negative 16. So negative 20 divided by 2 times negative 16. So it gives me 160. Oh, I forgot my parentheses on the bottom, so let me try that again. So remember, order of operations, we need to make sure that we do the whole bottom before we divide it by, before we divide the negative 20 by it. So this gives me actually 0.625. So at time 0.625, this marshmallow is going to reach its highest point. So not even 1 second into the flight. All right, so now we just plug that in and see what the height is at that time. So at time 0.625 equals negative 16 times 0.625 squared plus 20 times 0.625 plus 30. All right, so I'll type that in. Negative 16 times 0.625 squared plus 20 times 0.625 plus 30. I get 36.25 feet. All right, so we just need a sentence here. So how high is the marshmallow at its highest point? The highest the marshmallow gets is 36.25 feet. All right, so this concludes our notes. By now you should be pretty good at graphing a parabola and good at finding where the vertex is, which lets us know what the minimum and maximum heights are. All right, I'll see you in class next time.